Early 2026, a remarkable collaboration between Anthropic and Mozilla brought artificial intelligence into the spotlight of browser security. Anthropic's advanced AI model, Claude Opus 4.6, was tasked with analyzing the Firefox web browser for vulnerabilities. This partnership aimed to push the boundaries of what AI can achieve in the realm of cybersecurity, combining human expertise with cutting-edge technology. The result: a new chapter in how we approach software safety, with AI not just supporting but actively driving the discovery of critical security flaws. Let's dive into how this unfolded and what it means for the future of secure browsing. Anthropic's Claude Opus 4.6 AI model made headlines by identifying 22 new security vulnerabilities in Firefox. This discovery was part of a focused 2-week security assessment in January 2026. The vulnerabilities range in severity, with 14 classified as high, 7 as moderate, and 1 as low. These findings underscore the growing capability of AI to spot complex issues that might otherwise go unnoticed. For Mozilla, this meant a significant boost in their ability to patch and secure their browser, ensuring safer experiences for millions of users worldwide. The 22 vulnerabilities uncovered, the majority were deemed high in severity. This is particularly notable because the high-severity bugs found by Claude Opus 4.6 accounted for nearly a fifth of all such vulnerabilities patched in Firefox during 2025. By classifying the issues into high, moderate, and low categories, Mozilla could prioritize their response and allocate resources efficiently. This structured approach to vulnerability management is essential for maintaining robust browser security in an ever-evolving threat landscape. One of the standout moments during the assessment was when Claude Opus 4.6 detected a use-after-free bug in Firefox's JavaScript engine in just 20 minutes. This rapid identification showcases the speed and precision that AI can bring to security research. After the AI flagged the issue, a human researcher validated the finding in a virtualized environment, confirming its legitimacy and ruling out false positives. This synergy between AI and human expertise is setting new standards for vulnerability discovery. Scale of the operation was impressive. Over the course of the 2-week period, Claude Opus 4.6 scanned nearly 6,000 C++ files within the Firefox codebase. This exhaustive review led to the submission of 112 unique reports, encompassing both high and moderate severity vulnerabilities. Such comprehensive coverage would be a daunting task for human teams alone, but with AI, the process becomes not only feasible but highly efficient. Most of these issues were promptly addressed in Firefox 148, with remaining fixes scheduled for future releases. Mozilla responded swiftly to Anthropic's findings by releasing Firefox 148, which addressed most of the newly discovered vulnerabilities. This proactive approach demonstrates the importance of timely updates in maintaining browser security. Users who updated to Firefox 148 benefited from enhanced protection, while Mozilla continued to work on resolving the remaining issues in upcoming releases. The collaboration between AI and traditional engineering teams proved invaluable in accelerating the patching process. Anthropic didn't stop at just finding vulnerabilities. The team also challenged Claude Opus 4.6 to develop practical exploits for the issues it had discovered. By feeding the AI the full list of vulnerabilities, they tested whether the model could turn these flaws into real-world attacks. Despite hundreds of attempts and a significant investment in API credits, the AI succeeded in creating a working exploit in only 2 cases. This outcome highlighted both the strengths and current limitations of AI in offensive security tasks. One key insight from Anthropic's experiment was that identifying vulnerabilities is significantly cheaper and easier for AI than developing exploits. While Claude Opus 4.6 could efficiently scan code and flag issues, actually crafting a functional exploit proved much more challenging and resource-intensive. This distinction is crucial for security teams, as it suggests that AI is currently more valuable as a tool for defense, finding and fixing bugs, than for offense. To ensure safety during exploit development, Anthropic used a controlled virtualized environment with some security features intentionally disabled. This sandbox setup allowed the AI to attempt exploit creation without risking real-world harm. Even so, the successful exploits only worked within this restricted environment, underscoring the importance of layered security measures like sandboxing in modern browsers. Crucial innovation in Anthropic's process was the use of a task verifier. This component checked whether the AI-generated exploit actually worked, providing real-time feedback to the model. By iterating on its results, the AI could refine its approach until it achieved a successful outcome. This feedback loop not only improved the quality of the exploits, but also increased confidence in the AI's ability to produce effective patches for vulnerabilities. One of the most notable exploits developed by Claude Opus 4.6 targeted CVE 20262796, a just-in-time JIE miscompilation vulnerability in Firefox's JavaScript WebAssembly component. With a CVSS score of 9.8, this issue was particularly severe. The AI's ability to identify and attempt to exploit such a complex bug demonstrates both the potential and the risks of using advanced models in security research. Shortly before this disclosure, Anthropic had launched Claude Code Security in a limited research preview. This tool leverages AI agents to automatically fix vulnerabilities in code. While not all AI-generated patches are ready to be merged immediately, the use of task verifiers increases confidence that these patches address the specific vulnerabilities without breaking program functionality. This marks a significant step forward in automated software repair. Anthropic emphasized that while agent-generated patches passing automated tests are promising, they may not always be production-ready. Task verifiers help ensure that patches not only fix the vulnerability but also preserve the intended functionality of the software. This dual focus on security and stability is essential for responsible AI-driven development. Mozilla worked closely with Anthropic throughout the process, coordinating the disclosure and patching of vulnerabilities. In addition to the 22 main issues, the AI-assisted approach uncovered 90 other bugs, many of which were assertion failures or logic errors. Most of these have already been fixed, further strengthening Firefox's security posture. Interestingly, many of the bugs found by Claude Opus 4.6 overlap with issues typically discovered through fuzzing, a common automated testing technique. However, the AI also identified distinct classes of logic errors that fuzzers missed. This demonstrates the complementary strengths of AI and traditional tools, suggesting that a hybrid approach yields the best results in vulnerability detection. Mozilla highlighted that the scale of findings reflects the power of combining rigorous engineering with new analysis tools. By integrating AI into their security workflow, they achieved continuous improvement in both detection and remediation. This approach sets a new standard for proactive, data-driven browser security. Success of Claude Opus 4.6 in uncovering vulnerabilities demonstrates the growing role of AI as a powerful tool for security engineers. Rather than replacing human expertise, AI augments it, enabling faster, more thorough analysis of complex codebases. As AI models continue to evolve, their integration into security workflows will only become more essential. Despite the impressive capabilities of AI, human researchers remain a vital part of the security process. In this case, every AI-flagged vulnerability was validated by experts to ensure accuracy and prevent false positives. This collaboration ensures that the benefits of automation are balanced with the critical thinking and judgment that only humans can provide. While Claude Opus 4.6 excelled at finding vulnerabilities, its ability to develop working exploits was limited. Out of hundreds of attempts, only 2 exploits were successfully created. This suggests that, for now, AI is more effective as a defensive tool, helping to identify and fix issues rather than being used for offensive purposes. Anthropic's experiment also shed light on the economics of AI-driven security. The company spent about $4,000 in API credits during the exploit development tests. This investment was far more cost-effective for vulnerability discovery than for exploit creation, reinforcing the value proposition of AI in defensive security roles. Workflow established by Anthropic and Mozilla involved several key steps: automated scanning by AI, human validation, patch development, and coordinated disclosure. This structured process ensured that vulnerabilities were not only found quickly but also addressed responsibly, minimizing risk to users. Ensuring the quality of patches is a critical step in the vulnerability management process. Anthropic's use of task verifiers and automated tests helped increase confidence that each patch would address the specific issue without introducing new problems. This focus on quality assurance is vital for maintaining user trust and software reliability. Large language models like Claude Opus 4.6 are proving to be invaluable in the field of cybersecurity. Their ability to process vast amounts of code and identify subtle issues sets them apart from traditional tools. As these models become more sophisticated, their impact on software security will only grow. The partnership between Anthropic and Mozilla highlights the importance of continuous security monitoring. By regularly scanning for vulnerabilities and promptly addressing them, organizations can stay ahead of emerging threats. AI-driven tools make this process more efficient and comprehensive than ever before. For everyday Firefox users, these advancements translate into a safer browsing experience. Regular updates and behind-the-scenes security improvements mean that users are better protected against cyber threats, often without even realizing the complex work happening in the background. Success of this AI-assisted security initiative has broader implications for the tech industry. It demonstrates that integrating AI into security workflows can lead to more effective vulnerability detection and faster remediation. Other organizations are likely to follow suit, adopting similar strategies to safeguard their software products. Looking ahead, the role of AI in cybersecurity is only set to expand. As models become more advanced and datasets grow, AI will be able to identify even more complex vulnerabilities and suggest sophisticated fixes. The collaboration between AI and human experts will remain key to achieving the best outcomes. With great power comes great responsibility. Anthropic and Mozilla's approach emphasizes the need for responsible AI use, including rigorous validation, controlled testing environments, and transparent disclosure processes. These practices help ensure that AI-driven security advancements benefit everyone safely. The success of this initiative was made possible by close collaboration between AI researchers, security engineers, and software developers. By working together, these teams were able to leverage their unique strengths and achieve results that would have been difficult for any one group alone. Transparency was a cornerstone of the process. Both Anthropic and Mozilla made coordinated announcements and provided detailed information about the vulnerabilities and their fixes. This openness builds trust with users and the broader security community, setting a positive example for future disclosures. For software developers, this story offers valuable lessons. Integrating AI tools into the development and security lifecycle can dramatically improve the speed and quality of vulnerability detection. However, it's essential to maintain human oversight and rigorous testing to ensure the reliability of AI-generated results. End users play a role too. Keeping browsers and software up to date is one of the simplest yet most effective ways to stay protected. The rapid response to vulnerabilities in Firefox 148 highlights the importance of installing updates as soon as they become available. AI is also making strides in secure coding practices. Tools like Claude Code Security can automatically suggest or even implement fixes for vulnerabilities, helping developers write safer code from the outset. This proactive approach reduces the risk of security flaws making it into production. The integration of AI into vulnerability discovery could also transform bug bounty programs. With AI's ability to scan large codebases quickly, organizations may see an increase in the number and quality of bugs reported, leading to more robust and secure software ecosystems. Beyond vulnerability detection, AI is increasingly being used in threat intelligence. By analyzing patterns and behaviors, AI can help predict and prevent attacks before they happen. This proactive stance is becoming a cornerstone of modern cybersecurity strategies. Despite these advances, challenges remain. AI models must be continuously updated to keep pace with evolving threats, and there is always the risk of adversaries attempting to exploit AI systems themselves. Ongoing research and vigilance are necessary to ensure that AI remains a force for good in cybersecurity. The use of AI in security also raises important ethical questions. Ensuring that AI tools are used responsibly, transparently, and with respect for privacy is essential. Organizations must establish clear guidelines and oversight to prevent misuse and protect user rights. Anthropic and Mozilla's openness in sharing their findings encourages broader community engagement. By publishing detailed reports and collaborating with other researchers, they help raise the overall standard of software security and foster a culture of shared responsibility. Every vulnerability discovered and patched contributes to the ongoing learning and improvement of AI models. As these systems are exposed to more real-world data, they become better at identifying subtle and complex issues, further enhancing their value to security teams. The story of Anthropic and Mozilla is just one example of how AI is reshaping the cybersecurity landscape. Across the industry, organizations are investing in AI-driven tools to stay ahead of increasingly sophisticated threats. The lessons learned here will inform best practices for years to come. AI is empowering security engineers to do more with less. By automating repetitive tasks and surfacing critical issues faster, AI frees up human experts to focus on the most challenging and impactful problems. This synergy is driving a new era of productivity and innovation in cybersecurity. Regular software updates remain one of the most effective defenses against cyber threats. The rapid patching of vulnerabilities in Firefox 148 is a testament to the value of timely updates. Users and organizations alike should prioritize keeping their systems current to benefit from the latest security improvements. As we look to the future, the integration of AI into cybersecurity will only deepen. With each new breakthrough, the balance between automation and human expertise will continue to evolve. The story of Anthropic and Mozilla is just the beginning of a much larger transformation in how we protect our digital lives. Recap: Anthropic's Claude Opus 4.6 AI model uncovered 22 new vulnerabilities in Firefox, leading to rapid patches and improved browser security. The collaboration between AI and human experts set a new benchmark for responsible, effective vulnerability management. As AI continues to advance, its role in safeguarding our digital world will only grow. Partnership between Anthropic and Mozilla is a powerful example of how AI can be harnessed for good in cybersecurity. By combining the strengths of advanced models and human expertise, we can build safer, more resilient software for everyone. The journey is just beginning, and the future of secure browsing looks brighter than ever.